is the top, say, greenhouse gas. But the second one is methane, which is CH4. And of course, that's one that's considered to be very dangerous in terms of what it does back on the surface of the Earth for us. And so this is also showing the different color arrows are showing the different kind of types of land use and how they're projecting dangerous GHGs, greenhouse gas emissions, back into the atmosphere. So we know we have this trouble, we have an imbalance of how much we produce, 80 million tons, how much kind of carrying capacity of the Earth is to put that back into the Earth's systems, which is about half of that. So the other half is what we have to try to find new ways to sequester, either lower it, hopefully, but also at the same time find new ways, new places to put it. So I keep that simple because it's quite complex, but I think you have to only know either right. So often what is brought into the fore, again, we're creating more and more greenhouse gases. As time goes by, because the Earth, global warming is creating a lot of bigger consequences for the entire globe, we have less place to sequester it. We have less melting, we have different seas no longer need seas because they're being chopped down. So often, of course, it has to do with heat, but forests are also considered a big motive for, again, having more biomass. But at the same time, we are continuing to chop down our forests, right? So we know how important they are globally, and at the same time, they're still being obliterated, basically. Belgium is amongst our biggest obliterator. It's one of the least, it's doing the least amount of reforestation because they keep building basically Flemish sprawl. Why are forests being cut? They're being cut for wood products. They're being cut to make room for grazing, for agriculture, and for housing. So also we know as more roads are cut through the forest, more edges are exposed, and they're more suspect. So we know, if you remember, those of you that took landscape urban as well, in ecological terms, we want to have as much edge as possible, right? For biological diversity and life. But in forest, there's also a paradox. So the more edges you make by cutting it, the more you expose it to biodiversity, including pests and disease. So it's kind of, it's a balance to be thought of. So here we understand what are the major forces globally where we're losing massive amounts of forest. Of course, then what's interesting is a tree isn't a tree and a forest isn't a forest. No? It depends very much on the type and the size. So I think this is also a very interesting understanding to understand. So where we have the strong CO2 and where it's more moderate, and also where we have strong backward cooling. So the tropical forests are considered, say, the best in terms of the processes of being able to control things. That's why there's a kind of alarm of what's happening, particularly in Amazon, but other tropical regions that are, say, considered little hotspots because of they have a much bigger capacity than other kinds of forests, right? So it's all very dependent on the type. The interesting thing to know about all these forest types and in general about what we call biomes, so different kinds of climatic systems that make different forms of life possible, is that they're also affected by global warming. So they're moving, no, they're not static. So these kind of, if we could paint bands around the globe, once upon a time we could paint a band where the tropical forest is, but that's also moving. where a kind of, say, super arid, what we saw last week, where that is, it's also moving. So none of these things are static, which also makes it interesting to know. So the tropical forest is, as I say, the one that's considered more strongest in the sense of carbon sequestration. It usually consists of very tall and dense growing trees, both broad-leaved evergreens, and it's of course where we have high rainfall. That's why it's tropical. So it's often called also just a rainforest. So it's another word that comes in for this. So again, one of the problems, you could say, in looking at carbon sequestration, and also something that eventually creates heat islands that we'll hear more about, is somehow connected to the kind of transformation of our forest systems. So we're tending to get much more fragmentation. And we know, to a certain degree, having more edge conditions is considered good bioecology, because it's at these edges where we have more processes happening. But it's always this kind of, again, this delicate balance to have, because once you reduce a forest that we see here into 16 little forests instead of 1 hectare forest, you also lose. It's too much fragmentation to have a certain degree of biological relevance, right? So it's always understanding. It's never so simple as we think it is. It's always multi-dependent. Always then again on which type of landscape system are you talking about, in which climate, and with which pressures. So again, this is I think an interesting thing to understand. What's so interesting about working with landscapes and landscape systems